So this is lecture 2 of our Intro to Troubleshooting and Logic class. Today we're going to learn what troubleshooting is, what that means when we say that word. I know we tossed that around a lot already in this course, but we haven't even defined it, so we should probably go ahead and give it an operating definition. All right. So I guess I kind of just gave you a summary. We're going to run through it again for sake. All right, so the summary of today's lecture, we're just going to basically, like I said, go through a few terms, one of them being troubleshooting, the other is logic. We're going to use that term a lot in a few different ways, but we're going to define it today, give it a good working definition, same thing with troubleshooting. And then we're going to talk about some of the requirements that make up, or some of the requirements that you'll need to satisfy in order to gain the proper skill set to be an effective troubleshooter in an engineering application. All right, so like I said, we're going to talk about logic, and logic is obviously a big part of the course. It's the title of the course, so you're all smart enough to figure that out by now, I'm sure. Okay, so what does logic mean? When we say logic, like something logical should feel good in your gut. It should feel like it makes sense, and the reason that is because there is a proper order to do most things, and so the logical order, or in this case, like the logical process, is the chronological order of events that take place, events or actions that take place in order to satisfy some larger, more meaningful task or operation. The most simplest, I mean, that was a lot of words, and there's actually a really nice long mathy definition for this as well. If you want to look at that, it's terrifying even for me. The easiest way to like really apply logic is just to let's look at some examples. But the simplest logical statement we have on the bottom here is just an if-then statement. So if A happens, then B happens. In this case, I have if it quacks, walks, and acts like a duck, then it is indeed a duck. If I, excuse me, if the temperature is below 0 degrees C, then it is freezing temperature. You know, there are basically these consequences that are just a result of a prior situation or scenario that occurred. And the results of the scenario dictate what happens next. This is a logical process. It follows logical operations. All right, so let's just look at a simple example. We're going to start obviously very, very simple because I really want to just kind of pound this into your head because we're going to use this moving forward for everything we do. So the example I have here today is let's make some toast. Okay, easy enough. If I break down step-by-step operations for making toast, we have here 5 steps. So get the bread, put bread in the toaster, start the toaster, wait for the toaster to go pop, and then finally we'll take out our toast. So that's 5 steps. Okay, that's something we can all, we can all put ourselves there because we've all done this before at some point, assuming. Okay, so now we're going to put that into a logical form. So first we're going to start with, the bread. Is it available? Can I get the bread? If the bread exists, then I continue to the next step. Here, if the bread doesn't exist, meaning you don't have bread, you just stop the process. Excuse me. And there will be things like that occur. If if you see that there's serious damage to a belt or something like that, you don't continue to stick your hand in the machine and try and figure out, is there any other issues with it? You just simply stop the process. You cease to troubleshoot because either A, you've identified what needs to be fixed, or you'd identify a problem, but it's dangerous to continue the process. But it also just doesn't make sense. All right, so the second step is plugging in the toaster. So if the toaster is plugged in, then the heating element works. If the toaster is not plugged in, the heating element doesn't work. Step 3, we're going to push the lever. We're going to actually put the bread excuse me, in the toaster. The input causes an event. So we are like a user input. We by pushing the lever down, we now start this whole new process that occurs inside of the toaster. And you can think of the toaster as also being one of these if then, kind of contraptions, boxes. If the lever's down, the toaster will get hot. The irons will get hot. It'll run electricity through the heating elements, and it'll get hot. If the lever's not down, it doesn't get hot. So it itself is its own little if then. Finally, the heating elements actually toast the bread. So this has some sort of cause and effect. This is also something, again, that's just like this is in your gut. It may take some work to get it like kind of written down or thought about it in this type of way, this if then, or the way we have on the right here. It might take a little bit of practice to get it in your brain like that, but these things do just kind of make sense in your gut. So in a lot of these things, just go with your gut. But again, the heating element gets hot. This causes the bread to toast. We have a cause and we have an effect. Finally, the toaster pops. This signals to the user, hey, this process is done. And then now there's a user required input where I have to remove the toast. And if I wanted to use the machine again, I'd have to actually put bread back in the toaster and then push the button down. So this is like, again, all we're doing is making toast, but now we've actually broken down step by step, each of these 5 steps we have, and put them in a logical format. And we can see this logical process. There's a few places where this would actually, again, you'd break the process because it doesn't make sense to continue. And that's most easily shown in this type of format. So in like this is called like a flow diagram, flow chart, a box diagram, however you want to think about it. Basically at the top here on the right, we have the start. And from the start, that's just the start of any process. So the first thing we did was get bread. Okay, is the bread present? If it is, then I continue down. If it is not, then there's a little no that breaks off to the right of the diamond, and we're done. The process is done. You can't make toast without bread. So if I do have the bread, I continue down. I insert the bread into the toaster. Is the toast done? I remove the toast. If the toast is not done, oh, there's a mistake here. All right, so this is actually Chat GPT generated. Really, is the toast done? Let's see if this is surely going to be a little clunky, but we're going to try. Here we go. See if I can draw it here. This is happening. I don't know. Okay. Yeah. Okay. Let's just do this again. All right. Here we go. That's probably just gonna get trimmed out of the video. There's a mistake here. This is incorrect, so I need to remove that. Okay. So logic key points to summarize what we just talked about. Logic is following the proper sequence of actions. So following, performing a few actions or events in order in a sequence in order to accomplish a more significant task, in order to move on to a subsequent task. Logical statements such as if and then are the method in which like machines communicate to one another, machines communicate to us, machines communicate within the machine itself to various components. These little if then statements are actually built out of electronics, and this is how all modern computing works. So we're going to learn basically the building blocks of every computational machine created since Alan Turing made his in World War II. So visual aids such as like the flow chart, we'll use tables and stuff like that, are really helpful when trying to illustrate this logical process. All right, now we're going to talk about troubleshooting. So a few things that like came out of the book right away. The first chapter of the book's interesting because talks a lot about logic and troubleshooting, but doesn't actually define any of these things. So that's why I went ahead and defined it right away. I think it's ill advised to be using a term consistently in your text without defining it first. So we're gonna go ahead and just define it for Mati. I'm sure maybe it's in the forward. I don't know. But he's got a couple things in chapter one that he says that are just kind of goofy too. So he's got a couple things where he's trying to illustrate, basically troubleshooting is it's he's got here. I'll just give you the quotes. He's got here. Troubleshooting is an art form, and I put no wise man ever said. And the second one is troubleshooting cannot be taught, and I have this labeled as simply literal nonsense. And the reason that I chose those two captions for the quotes from the text is that it is actual just nonsense. I mean, there's two parts. So Marty goes on to discuss actually. There's two parts of troubleshooting. There's two key components of like your skill sets that you need, and we'll talk about this too. But you need to be taught how something works before you'd ever understand. There's nobody in the known universe can walk up to any machine and just know how it works. That's actual nonsense. You have to have some background education, and then with that being said, you need to have your hands dirty. You need to get your hands dirty. And so no, this is there. It's not an art form. When people say, "Oh, that something is an art form," that means you just have to be inherently good at it. Like your gut does it for you. And there will be some things where you are working on something and you do have a good instinct, but your instinct is dictated by your previous experiences, and so those previous experiences are actually what you bring to the table, not your gut instinct. Um, so troubleshooting itself, here we have troubleshooting is the process of discovering and resolving issues. In this case, specifically electrical or mechanical systems. Okay, so that's two parts: discovering and resolving. The discovery and the resolution of these issues requires a combination of skill sets, which we just talked about a little bit. We're going to get into more thoroughly here. So the skills that you need, you'll primarily be gained in two different ways. So you'll have technical resources and you'll have experience or on-the-job training. These are actually broken down further into the textbook as he calls it information and skills. It's the same thing. Really, you need um, resources from a few different avenues. So I need to be able to find technical resources, manuals, instruction books, videos, stuff like that. People on the internet, like there's nothing you can take apart these days that some dude on the internet hasn't already ripped apart, and you can see what it looks like inside, what you need to take it apart and put it back together successfully. And then skills, being able to actually accomplish things physically and manually, and like that is not something that can be taught. So the information aspect of it, the first part of it, is the part that's taught. So it's not an art form. It's a skill set. It's a combination skill set, and you need a certain amount of education. You need a certain amount of understanding that you'll get from courses like this and other courses at Madison College. And then you actually need to go and get your hands dirty. You need to go touch stuff. You need to go grind your knuckles a little bit. You need to go actually like touch things in order to see how it works and translate it in your head from PowerPoint slides and notebook paper to real life machines and real life applications. All right, so in Marty's book, he's got what you need to be a good technician. He's got this circle. He's got this circle broken up into 6 little like subcircles of how you gain experience. Really, again, this is just skills and information. So the way that you acquire your skills is on the job training, and you can do this in obviously any sort of format, but it's really beneficial for you to work with people that have been there a while, or if you can work under somebody who's a journeyman or a master at whatever their trade is, actually working through an apprenticeship. And then mentoring and being the mentor and the mentee, I think that's correct. I don't know, is actually really important. So not only like obviously it's the obvious relationship that would be important to learning would be being mentored by somebody else who's more experienced, right? But actually being able to turn around and then mentor another individual who's say somebody that started a year or two after you, and you translating this information and these skills to a new person and you teaching them really, really strengthens your own understanding of your skill sets. And so you being able to convey information to somebody that has not seen it or done it or touched it or felt it or whatever, and you being able to describe a process or a method to that person effectively really shows your understanding of the material. So this is also really important, and it's a really good skill set. And then as far as the information, so this is the resources. So at your company, there's going to be company wide resources. There's going to be technical resources. There's going to be manuals. There's going to be even like the engineering support staff for, say you have a pressure transducer from Omega at it's 3 a.m. and your pressure transducer is going haywire, and you ran a voltmeter across it a million times. You can't figure out what's going on. A lot of those teams have engineering technicians that you can call. I don't know, 24 hours, but definitely during business hours, and get information from the manufacturer directly if you need it. Almost everything they can give you is available on the internet, and I feel like this is like one of the first generation of classes where I can really assume that everybody here is like, comfortable enough on the internet where if you want something, you can find it. And really that's a huge resource because you are your own search engine now. So this personal study aspect is really important. Finally, external training courses. So again, if you can think about it, some dude on YouTube's done it and taken it apart. So it's like almost one of the rules of the internet now. So external training courses are going to be widely available for most things, most applications, most machines that are commonly used. And if you have trouble finding, some external training courses, contact manufacturers and then just keep going up the line until, eventually you're emailing the guy that put the CAD file together for the machine. Okay. So we're going to talk about troubleshooting using a very simple goal. You're sitting at home, I'm sitting at home, and all of a sudden my TV remote is not working. I did not want to pay for YouTube Premium, so I get ads. The ads always come on like twice as loud as the actual thing I'm watching, the actual video I'm watching. And so I want to turn the volume down. I go to turn the volume down. Remote all of a sudden doesn't work. So there's a few different things we can do to troubleshoot this, to make the remote work. The goal here is to make the TV remote work. We want to think about this from an engineering troubleshooting kind of technical way of doing this. But there's also just your gut reaction, right? So inside of this remote, there's actually this big circuit. And by the end of the semester, you should be able to read things that look like this. But there's this big electronic, there's a little circuit board, and on that circuit board, there's all these little components. There's actually electricity that flows through that circuit board and these components in order to function, in order to do things. In order for me to just hit Netflix or Disney Plus, there has to be some sort of operation that happens inside the remote. And basically, you can represent that using a schematic that looks like this. So if the remote is not working and I go to hit volume or I go to hit the Netflix button, I could dissect the entire remote. I could bust it open, and look at component by component over the entire circuit board. What is wrong? Like I gotta find, is the laser not firing? Or the little is the light not showing? Okay, well, if that's not showing, well, are the buttons working? I could go through all of that. We could go through it just, basically from left to right and not really give any real thought to how we're tackling this problem. Or we could live in a real world and think about it for 30 seconds and decide that's maybe the worst way to do it possible. So there's a logical process in this troubleshooting where I'm not going to start troubleshooting this remote by ripping it apart. No. The easiest place for me to start is, of course, the batteries, right? So, for sure, let's check the batteries before we do any sort of dissecting on this remote. I mean, I also understand you bought a new soldering kit, you're excited to use it. I get it. Been there. But the remote for the TV is probably not the best option for your first project. Let's check the batteries. This is the first step, and it's logical, and in your stomach, this makes sense. This feels right, and it's because it just is. So when we decide how to, in this case, looking at it from an engineering technical application, when you're troubleshooting something, you want to think about how much time, energy, and resources are spent into each and every one of these steps. And from there, you can kind of choose which steps I can just perform right away. And in this case, checking the batteries, replacing the batteries is a very quick process. It's not like costly. It's not. Um, it doesn't like require a lot of downtime for the component. This is just a very simple thing we can just get right off our checklist, and it's also the most likely scenario. That is the highest failure rate. We'll talk about this chapter two, but basically each component within our device has some sort of failure rate associated with it, and when we're talking about DC batteries, they have by design and it's not failure rate. Maybe it's not the best term for it here, but they have a discharge rate and therefore a limited amount of time that we can actually use those. So yeah, batteries. I'm not gonna. This is nonsense. This is why would I again? You don't want to rip apart the remote. The first place we should go is batteries. This is the logical way to troubleshoot a TV remote. Yeah. Oh, and so it depends on the actual equipment. So this will be different. The actual process of troubleshooting a specific type of equipment will depend on that specific equipment. So if it is a TV remote, checking the batteries is the logical thing. If it's a tractor, it's a little hard for me. I mean, you can check the battery of a tractor. Actually, that probably if your tractor's not starting, that's probably the first place you'd start anyway. But say something that doesn't. Just if you have something else, your washing machine's rattling, um, a table's wobbly, your computer's not working, your laptop's not starting, any sort of thing. Batteries are a good place to start, but they're all really going to require different steps. Not all of those things can be done. I can't just give you like, here are 3 steps to troubleshoot anything. It's no, it's not. It's going to require a little bit of information about the actual equipment itself, and this is where the information or um, the information, the technical resources aspect of this course and other courses is very important. All right, so chapter one summary, just to kind of rehash everything we've talked about. So logic is the order in which a sequence of events or actions occurs in order to accomplish some specific task. It is chronological, it makes sense, and the reason it makes sense is because the whole goal of the sequence is to accomplish some task. This is a little like meta, but we just have to like get this in our heart and soul, and then moving forward, using logic in everything we do, it'll just be an instinct. We don't have to think so much about it. Troubleshooting is the discovery and resolution of technical issues. And this is again in electrical or mechanical systems for this class, but and for most of the applications we're talking about. But so the discovery and resolution requires a combination skill set. And we also talked about this, and the only way we're actually going to acquire that combination skill set is basically we have to take 2 parallel paths. So simultaneously, we need to get experience. Like we need to get in on the floor. We need to be boots on the ground. We need to be hands dirty. We need to be touching stuff. We need to be fixing stuff. We need to be actually like, running code or working through the equipment, working with the equipment. That takes time. That's on the job training. That's just experience. That's one parallel path that we're going to take. The other parallel path is this knowledge aspect. And this is just something that no one can physically possess all of this information to themselves. If you're very knowledgeable about one specific machine, you're like not as effective as if your knowledge is spread over an array of machines or devices or an array of fields. Even the world's leading specialists for anything typically lend their expertise to fields that are slightly adjacent. Not everybody is just, I'm only very, very good at 1 or 2 things. That makes you very worthy or very, I guess, very valuable if that equipment is the only equipment being used in that space. If there's any other competitors where there's any other type of equipment that's being used and you're not that expert, then that really narrow skill set is gonna come back to bite you. So this combination of experience, actually working on the job, and knowledge, learning material and learning how to access outside resources is really important. Out of those two things, that those are going to be your big two tools um, going forward as you learn to become a good engineer and an effective engineer. That's what that means. Okay, so now we're going to go through some of the quiz one questions. So this is really just, like I said, a common sense check. Besides, I think one of them was a little weird. So the success of your training is up to, and it's oh, there we go. It's you, your company, your supervisor. It's anyone that cares about the company. It's literally anybody involved in the process. Everybody a part of your company, including you, your boss, like every HR, everybody involved. That you joined, your success and your training should be very, very important to everybody involved with that process, because it not only does it save the company money to like effectively and efficiently train you, but it also makes you a better producer or a better like asset to the company if they do effectively train you. So this is very important to everybody involved. OJT, my slides don't work. OJT, so this stands for on the job training. Um, this book is going to use this acronym a lot, so that's why they asked this. Mentoring it's basically just a transfer of knowledge. It's a transfer of knowledge between experience and inexperience, and then the inexperience become the experience, and that whole process just repeats. And that's the beauty of a mentor-mentee relationship. This question is super weirdly worded in Mattia. I have no idea which of those answers actually is right in the book. So, regardless of what you put on your quiz, hopefully you've answered your quiz. If you guys have not done your quiz yet and you watch this video and then do your quiz, just write in number 3 that you watched the video, and I'll have a little laugh. Like, we can laugh together. But yeah, you can just literally write in like, this question's nonsense, or the answers are nonsense. CCST. CCST is also an acronym that's apparently going to show up a lot. This is Certified Control Systems Technician. So there's actually a criteria that you have to meet. There's some standards in order to hold this title, and this is something that this is a goal that you can set, and then this is a nice big header on your resume or on your CV. And the two types of experience that we're going to be learning from is information, and then we're also learning information. These are two types of ways in which we gain experience are learning information and developing skills. This is again in Mattia's nomenclature. So learning information, gathering technical resources, knowing how to access resources, developing skills requires experience, requires us getting our hands dirty. Yeah, so then just a few notes. So if you have not sent me an email, please do email me. That's just the first assignment. Assignment 1.4 is it asks you to basically like do a little research on something in your field. And this does not have to be like overly significant, but I do want you to spend a little bit of time on this. I do want people to actually put thought into this, and I want you to write up the report like you would write up a report to a superior, to a somebody who's the head of a company that you work for. I want it to be thoughtful. I want it to look nice. The points for the points awarded for the assignment 1.4 will be adjusted. Right now it says out of 25. It's going to be out of 100. And then the other smaller quizzes are going to stay out of 25. But I want you to actually, it's 1.4, 1.5. It's the one that has the prompt that asks you to write the report. But yeah, if you have any questions about this, email me. We can talk about it. Assignments for week 2 will be going live today or tomorrow. Right now it's 5 a.m. I've been working on this for quite some time and trying to put together the other one. The other one hopefully will be out today as well. But yeah, we'll have videos on time hopefully within the next couple days. So we should be up and running quite nicely here. And then future quizzes are going to be in Brightspace, so it's not so clunky. I appreciate everybody that has just typed it in, like, but I'll just have them actually entered in like a normal person and not look so crazy. So that won't be as clunky. That's it for today. If anybody has any questions or anything, please feel free to. You can actually should be able to comment under this in the Brightspace page. If not, you will be able to in the future, and you guys can have a little discussion under it. We can talk about things, so I can actually answer questions if they're related to the lecture in the video. So, um, yeah, thanks for tuning in, and we'll talk to you soon.